Hello grade 12s, we've got our examples, our revision examples, just to get us ready for the grade 12 questions. So we've got this whole long sentence paragraph here of what's going on in the picture. So BDC is a triangle in the horizontal plane, ABD is a triangle in the vertical plane. So basically what we're trying to get at here is that almost like if you're looking head on, AD might be, some sort of tower or perhaps a tree with a little bit of imagination. And then DC is heading out on the plane that we're standing on. So if you were standing over here, you'd be looking up at point A, but along at point D on the ground. I don't know how much sense that made. Hopefully the question by itself makes enough. So it doesn't really matter in some ways. That'll happen in the later questions because we just need to see two distinct triangles here. There's the triangle at the bottom, BDC, that has a lot of information. And there's the triangle at the top, ABD, that has very little information. So what's going to be crucial is if we can find out what BD is, we can use the information from the bottom triangle to get into the top triangle. So what have we got here? We've got an angle and a side opposite. And we've got an angle and we're trying to find what the side opposite is. So that speaks to one of our trig formulae and pretty much one of them only. And that's the sine rule. So I generally put the thing that I'm trying to find on the top left, just makes it a bit easier. And let's go. Well, BD over the sine of the angle opposite it equals, well, we got the side on top, so let's keep consistent here. The side needs to be on top. 50 over, well, that angle that's opposite it is 25, so sine 25. Now, to find out what BD is, all we need to do is multiply both sides by sine 28. Because if we multiply this side by sine 28, well, those cancel. What you do to one side of the equation, you do to the other. Okay, so we just need to punch that into our calculator. Mine's here somewhere. Let's find it and tap, 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 tap into the calculator. And we get that BD equals 55,54, and so it goes on. Now, we shouldn't round off too early, so I'm going to use the shift store in the calculator and I'm going to store that in the variable a. So I'm just doing that as my own little reminder. So when I use it in the next part of the question, I know that's where it was and I can use the non-rounded off version. Okay, so we've got what this is. Let's put it in the diagram so that we can see where it is and use it. Okay, and we're trying to find out now the height of the tower AD. So we've got that. Now our next goal is to find out what is the height of this tower AD. That straight line there. Okay. Well, we've got an angle and we've got the side adjacent and we're trying to find the side opposite in a right angle triangle. Hey, let's just use tan. So tan of 37 degrees is opposite over adjacent. I'm going to put the dot, dot, dot to show that I'm using the non-rounded off version. Oh, well, this is easy. If we want to find AD, we're just going to multiply both sides by 55,54, dot, dot, because then we're just left with AD. What you do on one side of the equation, you do to the other. So punch that into the calculator. And AD equals, what did I get you? 41,85. And that's it. Now it's questionable how many decimal places we should use. For the physicists in the room, you'll probably start questioning how many significant figures we have. But by standard, let's say that it's at 2 decimal places. So there it is. And let's even get some units in here. I think it was meters. Okay, so we spoke a lot, but hopefully got a good sense of this type of question. I'll see you in the next one.